Good morning, viewers. Welcome to MouShauk. Today, I'll be starting with the barometer. It is an instrument for measuring atmospheric pressure. Okay. So, before I start, I will request you to please to subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And also, uh, if you have any doubts regarding this chapter or any other chapter, please to write in the comment box, or you can also write at my email ID, that is kasturi74@gmail.com. Okay. And please don't forget to meditate before you start your day. So before we start our discussion today, we will concentrate on point of light for meditation for just 1 minute, and then we will start with the discussion. Okay. So more meditation. Let us concentrate on a point of light. Think that light is falling on you, and your whole body is being lighted up. You're feeling very light, as if you are weightless, feeling no tension, no heaviness in you. You're totally relaxed, feeling that you are being supported by God at every step, the feeling that He is helping you in every step of your life. You're feeling that you are getting interest in whatever you are doing and becoming successful in doing so. At the end of the day, you are thanking God for being on your side and helping you so much. And because of Him, you are becoming so successful in getting good marks in your exams. Okay? So let us thank God and end our meditation now. Okay? And do this before every studies which you are studying. Okay, every subject which you start, just concentrate for 1 minute and then start your subject, so that this will help you in remembering of whatever you are studying, recapitulating, and also reciprocating in your paper. Okay, so that will help you in every step of your life, not only on your exams, but in every step of your life. Okay, so let us concentrate on the subject now, come back to the subject. So that's measurement of atmospheric pressure. Here, the atmospheric pressure is measured by an instrument which is known as barometer. Okay, so there are three types of barometer present: simple barometer, Fortin's barometer, and aneroid barometer. So first, it was simple barometer, which was discovered by Torricelli. Okay, and he first designed the simple barometer using mercury as a barometric liquid in 1643. Okay. Next, what is the construction of the simple barometer? It is a hard glass tube of length 1 meter. So this is the tube which is 1 meter in length, which is made of a hard glass, and that is closed at one end. This end is closed, and the other end is inverted into a trough containing mercury. Okay, it is fit, and when it is inverted into the trough, the tube is already being filled with mercury, pure mercury with no air bubble inside it. Okay. Now, how to do that? First, we need to seal the open end with the thumb of the tube with the thumb, and then the tube is then upside down. It's made upside down a few times in order to force out any air bubbles that is present in it. Okay. The complete setup is then inverted into a trough of mercury in a way that the open end of the tube is completely immersed in the mercury in the trough, and the tube is standing vertical. So first you need to, if this is the test tube, see, if this is the test tube, you fill this test tube with mercury, pure mercury, without any air bubble. Okay. Then imagine that this is the open end and this is the closed end. Okay. Now in the open end, you put the thumb here like this. Okay. And you need to take it upside down like this, so that if there is any air bubble present, it will go out. Okay. Then slowly this tube is inverted like this. Okay. Vertically upside down like this. It should stand vertically straight. It should be standing vertically straight, and it is immersed totally in a trough like this, totally in the trough which contains mercury. Okay. It should be standing straight. The tube should stand straight, and the trough should contain mercury, and the tube should totally immerse in that mercury. Okay. Now, slowly we take up the thumb off from the open end so that no air enters into the glass tube. It is observed that after removing this, after setting up in this way, it is observed that the level of the mercury in the tube falls till its height. Like even it is done like this, no, the trough is like this, the tube is like this. The mercury level will come down from the top till this much. It will, there will be some open space inside it. There will be some open space. The mercury level in the tube will fall till its height above the level of the mercury in the trough becomes 76 centimeter. That is from the trough till this one becomes 76 centimeters. Till that length, the mercury level from the top, it will fall down. Okay. See, this is the length. The mercury will come down from the top till this much, and the height will become from this to this one will be 76 centimeter. Okay. Next, the atmospheric explanation of the simple barometer. The construction is complete. Now we come to the explanation. The atmospheric pressure acts at all points outside the tube. Outside the tube, the atmospheric pressure is acting on the surface of the mercury, that is in the point C. The whole area, the open space inside the trough, there will be atmospheric pressure acting on the mercury surface. Okay. The point A, the pressure at point A is what? Is due to the weight or the thrust of the mercury column AB. Okay. So the mercury level is in the, it becomes stationary when the pressure inside the tube at point A, which is at the level of the point C, becomes equal to that of the point C. So what happens? The pressure at point A, if this is the point A, okay, and here the pressure becomes, it is due to the weight or the thrust of the mercury column AB. This is the AB column, which is acting on point A. Point A is here, and the point, this column, this Mercury column has some weight on the surface field. So that pressure is at point A is due to this column, Mercury column weight. Okay, the mercury level in the trough, it becomes stationary. In the tube, it becomes stationary when the pressure inside the tube at point A is equal to that of the point C. Okay, this level at point A, that becomes stationary. That does not move further down. Okay, why? Because that level is equal to the point C level, equal to that of the pressure at point C level. Okay, it becomes equal to that of the point C level. Therefore, the point A level pressure will be equal to that of the point C level pressure. And so, therefore, the mercury level becomes stationary here. The mercury level does not fall further inside the trough. It will maintain the length of AB. Okay, now, therefore, the vertical height of the mercury column in the tube AB is equal to H. Okay, that AB becomes H, is the measure of atmospheric pressure, and this is known as mercury column in and is called the mercury column in the tube. And above the mercury column B, above the B level, it becomes what? It is the torricelum vacuum. There's some mistake in the wordings, but I'll tell you, this is the torricelum vacuum above the level B. The space which has been created after the fall of the mercury inside the trough. Okay, beyond B, beyond the point B, inside the tube, it becomes a vacuum which is known as torricelum vacuum, which is named after the scientist Torricellium, who discovered the simple barometer with the mercury as a barometric liquid. Okay, ideally there should be no air in this space. There should be total vacuum in the space. Otherwise, if there has been air inside this vacuum, that will exert pressure on the mercury column, and the mercury will come down, fall further inside the trough, and that will make the barometer faulty. Okay, so the point A is here on the surface of the mercury level on the trough T, on the trough, in the trough. Okay, so that AB length is equal to H. This A point becomes stationary due to the pressure which will be equal to that of the pressure at point C. Okay, so this equalization of pressure of point A and C makes the point of A become stationary and not fall further inside the trough. Okay, and this makes the AB column equal to H, the vertical height, which is the vertical height of mercury column. And this is known as mercury column. Okay, and above the mercury column beyond B, beyond the point B, is the torricellium vacuum, which is named after Torricellium, who was a scientist who first discovered the barometric simple barometer with a barometric liquid as mercury. Okay, so next we move on to the working of the simple barometer. How does a simple barometer work? When the pressure outside the tube gets lowered, that is on the surface C, when that pressure becomes lowered, then the resulting pressure on the mercury in the reservoir will also low down. Okay, so when the atmospheric pressure becomes low, okay, especially on heights where the atmospheric air pressure becomes low, that time what happens? the mercury reservoir, where the trough which contains the mercury as a reservoir, that pressure becomes also low. Therefore, more mercury will be emptying from the tube. As the pressure becomes low, more mercury will come down from the tube. Okay. And the height, that is H height, will denote less than 76 centimeter. Okay. Now, on the contrary, when the pressure outside is more, therefore the resulting pressure on the trough will be more. Reservoir, the pressure will be more, and more mercury will move into the tube. Okay, more mercury will move, force into the tube, which will raise the mercury level inside the tube, and H will become more than 76 centimeters. Okay, so the vertical height of the mercury column from the mercury surface in the trough to the level of the tube is a measure of the atmospheric pressure. Okay, so this vertical height of the mercury column from the mercury surface in the trough to the level of the tube, that will be equal to the atmospheric pressure. And that is what the barometric height at normal temperature and pressure at sea level is 76 centimeter or 760 millimeter or 0.76 meter of mercury. Clear? Next is factors which affect the barometric heights. What factors change the height of the barometer? Okay, first is altitude. With the height, the density, if we move to above the sea level, to the mountains, to the hilly areas, the density of air and the atmosphere becomes less with height, which, as pressure depends on weight, the atmospheric pressure also decreases with height. Okay, so weight decreases, therefore what? Atmospheric pressure decreases. Okay, so what happens? Pressure decreases with weight, and weight, as we move above the sea level into the hills, we will see that weight of atmosphere that decreases, and that also decreases the pressure. Okay, so therefore the reading in the barometer falls as it is taken up in the atmosphere. It falls by about 1 centimeter for every 110 meters of ascent. For every 110 meters of ascent, 1 centimeter of mercury level will fall. That is, if it is, say, above the sea level, one goes 110 meters. So 76 centimeter will form 75 centimeters. Again, another 110 meters, if one moves up, then another 1 centimeter will fall. That is, it will become 74 centimeter, like that. Now, second point, that is tilting the barometric tube. If we tilt the barometric tube, at any place, the atmospheric pressure supports a vertical column of mercury. If the tube is tilted, we know that the vertical, that the tube should be in a test tube, the glass tube should be in a vertical position. But if the tube is tilted, as the mercury will occupy a longer length in the tube, but the vertical height remains the same, since the atmospheric pressure has not changed. As the atmospheric pressure has not changed, even if the tube is tilted, it will remain the same, it will maintain the same height. The vacuum in the tube therefore decreases, but the vacuum decreases. If the tube is tilted in such a way so that the vertical height is below 8 centimeters, the tube should be filled with mercury. If not, the barometer is faulty. That is, if some air enters in it, then what happens? It will move. It will press on the mercury level in the tube, and that will give a faulty reading. Okay, false reading it will give. Okay, then again, cross section and length of the tube. As long as the atmospheric pressure is constant, the vertical height of the mercury in the tube must remain the same. Okay. So as long as the atmospheric pressure is constant, the vertical height of the mercury in the tube must remain the same irrespective of the cross-sectional area or shape of the tube. Okay, if the tube is dipped into the trough, the length of the vacuum keeps on decreasing. As more and more tube is dipped into the trough, pressed into the trough containing mercury, the height of the vacuum, the length of the vacuum will decrease. If the vertical height is below the atmospheric pressure, H, that is 8 centimeter, a metallic click should be heard and the tube filled with the mercury. If not, the barometer is faulty. Okay, metallic click should be heard and the tube should be filled with mercury. Otherwise, the reading will be faulty. The barometer will give a false reading. Now, dampness of the mercury. If the mercury is damp, that is, if a little water has entered into the vacuum, that will evaporate and that will create a pressure on the mercury column and that will give a false reading and make the barometer faulty. Okay. Next is introduction of alcohol in the vacuum. If a little alcohol is introduced over the mercury column, the mercury level falls as the alcohol evaporates and the vapor exerts pressure on the mercury column. After some time, the vapor is saturated and no further evaporation occurs. The mercury surface will then remain steady. Okay, but it has made the mercury reading faulty. Okay, false reading, that is. Then temperature. During hot season, the height of the mercury barometer falls. This is because hot air becomes less dense and rises. And thus the pressure falls. Okay, during hot season also temperature also affects because during hot season, the hot air that will rise up because it has become less dense and it will rise up and that will make the pressure fall. Okay? That will not give the actual pressure. Now, what are the advantages of using mercury as a barometric liquid? We know that Torricelli have introduced the mercury as a barometric liquid. Why? Okay, what are the advantages of using the mercury as a barometric liquid? First, its density. Density of mercury is 13.6 into 10 to the power 3 kg per meter cube, which is very high than any other liquid. So only 0.76 meter height of mercury column is needed to balance the normal pressure. While when we use other liquids, it will require a much longer tube. Okay, that becomes inconvenient. So we use mercury. Okay, then it has negligible vapor pressure. So the vapors in the Torricelli vacuum does not affect the barometric height. So vapor pressure, mercury's vapor pressure is very negligible. So it will not affect the barometric height if the vapors are present in the Torricelli vacuum. Now, its rate of evaporation is also not very high. Okay. Again, it neither wets nor sticks to the glass, so it can give an accurate reading. Its surface is shiny and opaque, and so it's very easy and convenient to take a reading from outside the tube. Then it can easily be obtained in the pure state. Mercury is easily obtained in a pure state. So these are the advantages which has made mercury as a barometric liquid. Then what are the disadvantages of using water as a barometric? We don't use any other liquid, especially water we don't use as a barometric liquid. Why? What are the disadvantages of water as a barometric liquid? First, it is sticky. It sticks to the wall of the barometer and which provides an inaccurate reading. It has a low density, only 10 to the power 3 kg per meter cube, and that is why it is A 10.4 meter height of water column is required to balance atmospheric pressure, and this is very highly inconvenient for a barometer. Such a long tube is needed, 10.4 meters, whereas in case of mercury, only 0.76 meters is needed. Now, water is transparent, so it cannot be easily seen from outside, and it is very difficult to take a reading or observation outside of the tube. The vapor pressure of water is also very high, due to which the vapor which is formed above in the vacuum space, that makes a pressure on the level of the water, which will create an inaccurate reading, which will create a pressure, and the water level will fall, and which will not give an accurate reading. So these are the disadvantages of using water as a barometric liquid, and that's why mercury is being used. Then what are the demerits of the simple barometer? See, simple barometer was first started, but later on 14th barometer came, and then analog barometer came. So what are the defects of this, demerits of the simple barometer? There is no protection of the glass tube. The glass tube is not being protected. Okay, the surface of the mercury in the trough is open. Therefore, there are chances of impurities may fall and get mixed in it, fall in and get mixed with the mercury in the trough. Then it is inconvenient to move the barometer in such a open condition with the no protection in the glass tube, no protection in the trough. So it is very inconvenient for such a barometer to move from one place to another. It's not portable at all. Then a scale cannot be fixed with the tube, or it cannot be marked on the tube to measure the atmospheric pressure. It is due to the fact that when the atmospheric pressure changes, the height of the mercury column also changes in the tube. This results in the change of the level of the free surface of the mercury due to its flow in and out, in or out of the tube. Okay, so what happens? When the pressure changes, when the height of the mercury column moves up, then the trough mercury lowers down. And when the height of the mercury column lowers down, the trough of the mercury rises up. So this level cannot be marked. Okay. The free surface of the mercury in the trough, therefore, will not remain coinciding with the zero mark of the scale. And if the scale is fixed with it to measure the barometer height, that would be more easier. But this cannot be done so in this simple barometer. So there are some demerits of the simple barometer. So with this demerit, another barometer was invented, that was 14th barometer. So in my next video, I will be discussing this 14th barometer. Okay, so till then, go through this. If you have any doubt, please write in the comment box. You can also access in my email ID. You can send me a mail at an email ID, that is kasturi74@gmail.com. You have links to my other videos of this chapter, as well as to my playlist of class 9 syllabus in the description box. Okay, you can refer to those and go to the biology videos which I've been discussing within this in between these videos of this physics chapter. Along with this physics chapter, you can get the links of those also in the description box. And also a new channel video is also being inserted in the link, is also being inserted in the description box. Please, you can refer if you are interested. It's a Bengali channel, spiritual channel. Okay, if you are interested, please refer to that. And do subscribe. If you have not subscribed yet, or new viewer to my channel, please do subscribe. Okay, and if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And please do meditate before you start your day. Make your chart of what you are doing. Starting, you make your chart, and at the end of the day, after completion of your routine, you just check whether you have completed, how much you have completed, and make a flow chart or a diagram. You can also do make a diagram and label in that, write along with it, with the diagram, labeling besides the labelings, so that it will be easier for you to remember and recapitulate. Okay, and that will help you in reciprocating in your papers. Okay, so thank you for joining and have a good day.